Page 32, partial fractions. This page right here is just formulas. For partial fractions, there's 4 different cases that you could see. There's distinct linear factors, repeated linear factors, distinct quadratic factors, and repeated quadratic factors. Now, we are given one of these cases, for example, on number 1, you could set up to find the solution as a matrix. You could also do this by substitution or elimination. So here's an example right here. We have 8x minus 23 all over 1x plus 4 times 1x minus 7. It would break this one fraction into 2 fractions. So the first thing we want to do is just get rid of the denominators altogether. No fractions on this. So we're going to multiply each term by the denominator of this one, x plus 4 and x minus 7. So on the left side of the equation, we have 8x minus 23. And on the right side, we have a times x minus 7, because the x plus 4 is canceled. And then we have plus b times x plus 4. The x minus 7 is canceled for that one. Now, we could distribute and combine like terms. We have x times a plus b, and then we have our constant, negative 7a plus 4b. So we know that a plus b has to equal 8. So we have 1a plus 1b equals 8. 8 x's. And then the constant is negative 7a plus 4b is equal to negative 23 constants. So the first row represents x coefficient, and the second row represents the constant coefficient. From there, you would solve the system of 2 equations. And you get an answer of 5 is A and 3 is B. And then you would just plug them in right here, and you have your 2 separated fractions. Let's look at the next one, repeated linear factors. We have 3x plus 17 all over x plus 5 squared equals a over x plus 5 plus b over x plus 5 squared. So we want to get rid of the denominators. So we'll multiply each of these 3 terms by x plus 5 squared. So we have 3x plus 17 left on the left side of the equation. A is going to have one of the x plus 5s left, and then b doesn't have any of them left because they all canceled. From there, you'll distribute and combine like terms. After that, you separate each coefficient. So we have the x coefficient, which is a, and then we have the constant coefficient, which is 5a plus 1b. The x coefficient equals 3, and the constant coefficient is going to equal 17. So if we set this up as a matrix, we have 1, 0, 3, and 5, 1, 17. When we solve that system, we'll get a equals 3 and b equals 2. And again, you can solve the system however you'd like. Number 3, we have distinct quadratic factors. So this example, we have 0x cubed minus 1x squared plus 0x plus 15 all over x squared plus 3 and x squared plus 9. So we want to break it into two fractions again, ax plus b all over x squared plus 3 and cx plus d all over x squared plus 9. So same thing as before, you want to get rid of all the denominators, so you're going to multiply everything by this expression right here. And on this side of the equation, we just have negative x squared plus 15. Once we do that, we'll distribute, combine like terms, and then separate each of the coefficients. We have the x cubed coefficient, which is a plus c. The coefficient of x cubed was 0. We have the x squared coefficient, which is b plus d, and we want that to equal negative 1. We have the x coefficient, 9a plus 3c, and we want that to equal 0. And then we have our constant coefficient, 9b plus 3d, and that needs to equal 15. Notice that's what we have when we set up our matrix. When you solve for the variables, you get a is 0, b is 3, c is 0, and d is negative 4. Again, solving the system is not the point of this section right here. It's being able to set them up so that you could break a fraction into parts. And then there's one other case that you can see. There's repeated quadratic factors. So we have this example, negative 2x cubed plus 3x squared plus 15x plus 7 all over 2x squared plus 3x plus 4 squared. And we're going to break that into two fractions again. We have ax plus b all over 2x squared plus 3x plus 4, and then plus cx plus d all over 2x squared plus 3x plus 4 squared. Do the same thing as before, multiply each term by the denominator to get rid of all the denominators. So then distribute and combine like terms, and then separate each of the coefficients that you're looking for. The x cubed coefficient, the x squared coefficient, the x coefficient, and the constant coefficient. X cubed, it looks like it has to equal negative 2. The x squared coefficient is 3. The x coefficient is 15, and the constant coefficient is 7. Set that up in the matrix or any system of equations you want to solve, and then you get a equals negative 1, b equals 3, c equals 10, and d equals negative 5. If we look at the next page, this is just the general case of each of these four cases. So instead of having numbers, they're each represented with letters. Now these letters are here because you can interchange them with whatever numbers you want as long as the denominator is not 0 or something. And you can set it up and put them in this matrix. If you put these specific numbers, whatever those numbers are, your given example, into this matrix, and you find the reduced row echelon form of those, you can solve for A and B. A, B, C, and D, and so on. Now, when you're doing these practice problems for partial fractions, you may want to practice just setting them up using these examples from before. But if you've done a lot of the practices and you're just trying to find a quicker way to get to the solutions, you may want to try the matrix formulas. Go ahead and pause the video, try to do this one on your own. We have 11x plus 1 all over x plus 3 times x minus 5. Which case is this? 1, 2, 3, or 4? So go ahead and work on this one. Alright, so you should have gotten case number 1. They're distinct linear factors. We have 2 of them. So we're going to be looking for A and B. So A over x plus 3 and B over x minus 5. And that's going to equal our given 11x plus 1 all over x plus 3 times x minus 5. So we're going to multiply each term by x plus 3 times x minus 5. So when we do that, those cancel, so we have 11x plus 1 equals A parentheses x minus 5 plus B parentheses x plus 3. From here, we're going to distribute and combine like terms. So we have 11x plus 1 equals ax minus 5a plus bx plus 3b. From here, let's go ahead and separate our coefficients. We have the x coefficient, which will be a plus b, because we're taking this one and this one. And then we have our constants, minus 5a and plus 3b. And that all equals 11x plus 1. So we're going to set up our system. We have a plus b equals the coefficient of x, which is 11. And then we have negative 5a plus 3b equals our constant, which is 1. So we can use substitution, matrices, or elimination for these. Let's go ahead and use elimination for this one since we haven't done that yet. So we can multiply this top equation by negative 3 and the bottom equation by just 1. So then we get negative 3a minus 3b equals negative 33, and then negative 5a plus 3b equals 1. Combine the two equations together to get negative 8a equals negative 32. Divide each side by negative 8. You get a equals 4. If 4 plus b equals 11, b must equal 7. So then we can write our final answer for partial fractions. So a is 4, so we have 4 over x plus 3 plus b, which is 7 over x minus 5. If you set these up using the least common multiple and combine like terms at the top, you should get what we started with. Before moving on, let's look at the other way we could do that with the matrices. So, from number 5, m equals 11, n equals 1, a equals 1, little b equals 3, c equals 1, and d equals negative 5. So let's plug all of those into the formula. Let's see what we have there. So we have c, so it's a 1, 1, 11. and then -5, 3, 1. And let's find the reduced row echelon form of this and see what we get. So on desmos.com/matrix, we could create a new matrix, type in those values. We have 2 rows and 3 columns. And let's type those in. We have 1, 1, 11, -5, 3, 1. Okay, let's find the reduced row echelon of matrix A. Notice we have a 4 and a 7, so A is 4 and B is 7, just like what we solved with elimination. Before submitting this unit, take some time to do your Unit 9 reflection. Summarize what you learned from this topic. What questions do you still have about the topic? How are you studying? Are there some studying techniques that you haven't tried yet that you may want to? Are you studying enough time outside of class? Or are you perhaps more efficient than the average student? And what are your goals for the next unit? How could this be even better?